And the last piece we're going to look at with acids and bases are reactions involving acids and bases. Now, we can see reactions of non-metal oxides and water, or types of reactions in the lesson. So, an example, non-metal oxide plus water will produce an acid. Okay. So an example might be CO2, which is a gas, water is a liquid, and we get H2CO3. Okay, so we get that oxyacid carbonic acid. That's an example. We've seen reactions of metal oxides in water, so we take our metal oxide, react it with water, and this gives us a base. So we've got our, let's say we use sodium oxide, and our water, which is H2O. And when we put this in, we can create our base, which in this case is sodium hydroxide. Okay. So there's a reaction that looks at our metal oxide and water creating a base. So this could be a solid, our liquid water creating our base, and because it's in water, we put aqueous beside it. Now these two examples that we've seen, these first two, these really are just examples of a synthesis reaction. That's all it is. Okay. So this one right here, our first one and our second one, are just examples of a synthesis reaction. Okay, so if we go back to our types of reactions part of this unit, those are really just synthesis reactions, those first ones, those first two examples. Now, our third reaction that we're going to look at is the reaction of a metal and an acid. So let's say we were to take a chunk of sodium and put it into an acid. So metal plus acid will produce something. And in this case, we end up with two products. So let's take a look at the reaction. We'll use sodium and we'll use an acid. Let's use hydrochloric acid. It's a nice, easy one to work with. When I look at this, I see an element and I see a compound. So immediately my brain should think, hey, this is a single displacement reaction. So the metal will take the place of the positive thing, which is the hydrogen. So we get NaCl, and we'll get hydrogen, which exists as H2 when it's by itself. So really, what we're getting is we're getting a salt and hydrogen gas. Okay, so this is what we see. And really, like I said, that's just an example of a single displacement reaction. So this one, we're into classifying them. Single displacement. I'm just going to shorten it there. Okay. So it's really just a single displacement example. All right, example number 4. Another reaction involving acids and bases. Well, what if I just take an acid and put a base in it? All right, let's take a look at that one. So when I take an acid and I react it with a base, I get two products: a salt, which is an ionic compound, and water. So acid plus base produces salt and water. So I always get those two compounds when I mix an acid and a base. So in my example, I use HCl with our base NaOH, and I will get the sodium will go with the chlorine. Hey, this is just a double displacement. Two compounds reacting, I can do a double displacement. So I get sodium chloride, which has the formula NaCl, and HOH, which is really just water. So we saw that little switch. The sodium took the place of the hydrogen, the hydrogen took the place of the sodium. That's what gave us the sodium chloride and the water. It's our double displacement. That's essentially what we're doing right there. So this reaction is a double displacement, but because it's a reaction between an acid and a base, and we're creating water and a salt, it has a special name, and this is called a neutralization. which is really just a form of double displacement. So I'm just going to put DD. It's a double displacement reaction. That's all it is. And our last reaction is a reaction if I take an acid and I put a carbonate with it. Now, if any of you have made your own volcano at home, you've done this. You've taken vinegar and you put it with baking soda. Baking soda is sodium bicarbonate. It's a carbonate. When I take acids and put them with carbonates, I get a neutralization occurring, but it's a special type of neutralization that's got three products. So I get a salt and a water, but I also create something that causes bubbles when it's in liquid, which is a gas. And that gas, in this case, is carbon dioxide coming from the carbonate. So our general reaction for this one is a carbonate plus acid produces salt. Remember, salt is just an ionic compound, water, and carbon dioxide. So this is a reaction that we would consider to be a neutralization. It's just a neutralization of a carbonate. It's a little bit different because we get that third product produced. So let's use the example NaHCO3. So this is sodium bicarbonate. And we'll use hydrochloric acid, HCl. I get my salt, which is NaCl. I get my water, which is H2O. And I get my CO2 gas, my carbon dioxide. So that's our reaction of our acid and our carbonate. Those 5 reactions are all reactions that involve acids and bases. But essentially, you can classify them as reactions that we've already looked at. Our first 2 are synthesis, our reaction of a metal and acid, single displacement, and then our last 2 are really neutralization reactions, which is essentially our double displacement. But when you've got a carbonate, you get a third product produced. So it's a little bit different type of neutralization. And remember, neutralization, you're always going to make a salt and water. That's the key thing to remember. Always making a salt and water. If we take a look at our example that we had before, we had an acid. Right? We had our acid. When it's in hydrogen chloride form, you put it into water, it dissociates into H plus and Cl minus, right? Our base, when you put your base in water, the sodium hydroxide, okay? The sodium hydroxide dissociates into sodium ions and hydroxide ions. But we know that the sodium ions will come together, that's our sodium chloride, that creates the salt part, and our hydrogens will react with the hydroxides, and that's what creates our water. So essentially, we're bringing these 2 things together. Okay? That's what's giving us our water. So those 2 together give us our water. The Na plus and the Cl minus come together to create our sodium chloride. So you see those ones coming together. And that essentially is our neutralization reaction, which is why when we're done, we don't have any H plus, we don't have any OH minus. We've just got our nice water and our salt, why we call it a neutral solution, because there's no difference in the amount of H plus or OH minus in this container after mixing the acid and the base. That's our neutralization.